There we go. Now I'm recording. All right. So remember, classes will close next Friday at midnight. So you have until then to get everything in. And since everything is open, no, it closes 2021. What? 2021. I was in a meeting with Principal Dan and and he did say midnight. I will double check that like right now because he did tell me midnight because I asked. But I'm gonna ask. Dan. Who else can I ask? Jim. Heidi. You know what? I won't.
They're telling us different things.
Wait, what? Yeah, I'm gonna ask. He told me midnight, so I will ask and I will clarify that for you guys. Thank you guys for telling me. Hi, friends. When do classes close? Is it midnight or 3 p.m.? Okay. So, could be 3, could be midnight. I will check on that. Dan did tell me midnight, but a lot of you are saying 3, so I'll let you know. I will send you an email as soon as they tell me. Hopefully they will tell me while we're in class right now. So
yeah, all the different classes have different times.
That's weird.
Like our science class is telling us that she can't grade anything past 3 and that she won't let us do anything past 3. So I don't know. I just know that that's what our science teacher is saying for our class.
Okay. So I would set it for midnight. Because we don't have to have grades until that Monday. So yeah. Yeah, next week Friday. If they're saying it's a teacher preference thing, I will learn how to set it so you guys can do it till midnight. But yeah, I will clarify that as soon as. But it's definitely Friday. I would shoot for being done at 3 because I wouldn't want to work until all hours of the night, you know? So yeah. Right? You got to crush it next week. What's crush week? I don't know what that is. Is that what you mean? I'm sorry. Oh, hello, Miss Elsa. Oh, is that good?
I can drink all of it.
Yeah. Oh, very good. Okay, go watch Dino Dina. Right. Yeah, I'm going to check. If I were you, I would just shoot for being done at 3, personally. That way, it's Friday, you can be done. But, yeah. Oh, I like that. Okay, so today we're going to talk about transformations, the review here. Okay, remember, just kind of reviewing this stuff. I'm going to give baby her little Nook thing while you guys go get piece of paper, notebook, whatever you need to write a few questions down. I'll be right back. Hey, baby. Hey, baby. Hey, baby. Hey, baby. Oh, my God. Hey, baby. Don't you want to banana? Yep, it's math time. Get serious. Okay, it's a real problem when baby keeps smiling at you and her Nook falls out. Oh, babies, I tell ya. Okay, so remember, translations are a slide of a figure with no change to shape or size. Okay? No change to shape or size. That is a translation. It's a slide. It's when a figure moves from one position to another. Okay, remember when we talk about the translations, these are those notations that would be really helpful to have. Oops. Excuse me. But they will either tell you a description, they will either show you a mapping of the translation, or they will give you a symbol. It will tell you what to do. And if they give you a symbol, this means a translation of 3 to the x and then -2 to the y. And remember, when you go +3, it's +3 in the positive direction. You guys got to think of the coordinate grid. Okay, these are the positive x's. These are your negative x's. Positive y, negative y. Okay? So just think of it on the coordinate grid like that. Okay, +3 goes, and then you can even just count it out. It's just moving it on. It tells you how to move it. If you have a point that's at like 1, 1, and you don't even have to focus on adding or subtracting. If they want you to go 3 to the right, you count 3 to the right. 1, 2, 3. It's there, and then 2 down, 1, 2. So here's our new point at 4, -1. Okay? Does anybody need to write these down? You should have them down from last time, but if you need to write it, let me know. Speak now or forever hold your peace. Right? And remember, when you translate a point, a prime or something prime, they'll have a little prime thing. That means the point, the new point that just got translated. So, very good. Questions? No questions. Anybody needs to write it down. Everybody alive out there. Let me know you're alive out there. Hey yo. Boop. I live. I love it. No, Tyler says no. Okay. Okay. Dallas, are we here? I feel like there's a lot of people listening. I feel really honored.
Yeah, I'm here.
Hi, Dallas.
Hi.
Just planning with your mom. Cool. Cool. Okay. All right. So we're going to get into some questions. Okay, so we want to translate this triangle here. Okay, thank you for letting me know you guys are alive out there. Oh, baby's sleeping. This is the easiest baby, I tell you. What am I looking at on Dallas's screen? Is that a light? Looks like a pimple. That's what sorry. It does. It's like, whoa. Okay. Anyway. A light. Got it. And 2. No, don't be dead. Okay. So first thing we're going to do is there's a few things we can do to translate this point. We can first just count it out. Okay. A translation of 3, -2 means we're going to move every point 3 to the right toward the positive x's and then 2 down. That's what that means. Okay, remember this is always x, this is always y, and if it's positive, you go toward the positive x's. If it's negative, you go down toward the negative y's. Okay, no bopping. All right, so we could just move it either way. We could take A and we can go 1, 2, 3, 1, 2. Here's A prime. So all we got to do is just count it out. No bopping. No booping. Okay, so another thing we can do is we can list what the original coordinate is and then just add or subtract to it. So can someone do me a favor and tell me what the original coordinate of A is? What is A at? And we can double check if we get the same thing. 2, 8, Tyler says. Tyler is correct. Very good. A is at 2, 8. Now, we can just move it and count it out on the graph, or we can add 3 to that x. So 2 plus 3 gives me 5. If I add 3 to x and then subtract 2 from my y. So according to this, I should be at 5, 6 for A prime. 5, 6. I am! Yay! So it works out either way if you count it or if you just add or subtract. That's it. So who can count it out for B? Who can translate B for me? Can someone raise their hand? Oh, B is at 2, 5. Beth said. We will put that in. Perfect. Thank you. So who can do the movement for B? Someone raise your hand and translate B for me. Who could count it out? You're just going 3 to the right and 2 down. That's it. And then putting a dot and labeling it B prime. Don't all volunteer at once. Seriously. Not so, we can't get so excited. Oh, beautiful. There we go. Beth, could you please translate B prime? And then Allie, would you mind doing C? Could you count it out for C? So Beth, you'll do B, and you'll put the new dot on the map there. And then Allie, you can do C. So, and again, what they're doing is they're counting it out. They're just going to take where B is and count 3 to the right and 2 down. That's it. And then where C is, 3 to the right and 2 down. Oh, C is at a weird point. Should we just pretend it's like right here? I'll leave that up to you, Allie. If you just want to pretend it's right there, that's fine. I think that's what was intended. Yeah, you're not going to have to deal with decimal movements. That's too tough. Okay, so go ahead. You should be able to annotate on there. Once you're ready, Beth, and yeah, seriously, do your thing, girly. Oh, this is the sweetest sleeping baby. I'm so excited. Who is that peeking in? Is that an older bro? Sis? Couldn't tell. Saw him really quick. I'm fascinated. And you can count from that too. Yeah. That is a really good suggestion, Tyler. I love what Tyler said. Tyler said that you don't even have to move it. You could just see that B is 3 spaces down. So all you could do is just go 3 spaces down. That's a great suggestion. Seriously. You just got to count it out on the graph and use what makes sense. It's perfect. Because that's 1, 2, 3. And I love the color, by the way. Yes. Very good. Very, very good. And Darren says he leaves his open till midnight. Okay. So I'm going to say, where is a setting just so I can make sure it's open till midnight? Hi, Darren. Thanks for replying. Where would I check on Moodle to make sure it's open till midnight? Okay. Cool. Yeah, it's probably just the settings thing. Oh, baby, did you drop your thing? Oh, and we got C prime on there. Perfect. Wow, that's perfect. Oh, baby, did you drop it? Then don't drop your nana. That's a good girl. Okay. You want your music again? Okay. Guys, that's perfect. Very, very good. You could clearly see that C, you could use Tyler's reasoning too and just kind of reason it out. It's about 2 diagonally away from the A, or you could just count it out. 1, 2, 3, 3 to the right, and then 2 down. Very good. So then here is our new triangle. You want this?
What are those?
Those are fruit snacks.
No.
What? Okay, you gotta go sit down so I can finish. Go sit. Okay. Or you hang out with baby Evelyn there. Okay. There is our purdy new triangle. And you can kind of check that. If we checked it with the settings, if I added 3 and subtracted 2, I would get 5, 3. So it's kind of cool. You can see those X's are the same. Very neat. Good stuff. Anybody have questions on this? Oh, honey, don't throw the ball. You could hit baby. Go throw it over there. Just don't hit the TV. That'd be bad. Anybody have questions on this? We did a perfect job with our translations. We could say if we did it for C, it'd be at 4, like, I don't know, if we said it was 4, 7, we would add 3, so we get 7, subtract 2, 5. Okay, good. Good stuff, guys. So that's translations. Translations. Okay, so now we want to pick the translation. So what happened here to X and Y? And we're not using... Oh, I'm sorry. I'm going a little slow. I'll pick up the pace, I promise. But to be fair, the examples are very focused, so there's not that many. We're good. Husband, don't call me now. Okay, so what happened here? What do you guys think? Go ahead and raise your hand. We want to pick the translation of going from E to E prime. E to E prime. What did they do? Go ahead and raise your hand. Raise your hand. I'm also a talker. I'm sorry. I'm a little slow there, but I appreciate the patience and the motivation to pick it up. So I appreciate both of you. All right, so what do you guys think? From E to E prime, what did they do? Beth and Ellie. Ooh, Casey. Oh, Casey, I like your picture. Casey, what do you think, my friend? What is it? Which one? And then I'm going to confer. Casey says 4. What do you think, Wolfstalker and Beth? Do you guys agree?
Technically, it's neither of these because... Oh, never mind. I looked at it wrong.
That's okay. And that is easy to do because you're really focusing on E to E prime. It's so easy to go from left to right because that's what we're used to and conditioned to reading. So you guys are saying 4, so let's check it. So that means 4 to the right and 3 down. So 4 to the right, because we're adding 4, that's 4 in the positive direction. So if that were the case, I'd start at E and I'd go 1, 2, 3, 4, and then 3 down. That would put me over here. So I don't think it's 4. What do you guys think? 3. Let's try 3. So it's 4 to the left now and 3 up. 4 to the left. So we'll start at E. 1, 2, 3, 4. Bingo. 3 up. 1, 2, 3. Perfect. You're right. So it is 3. That is a classic thing to do, is to go from here to here, because we are used to reading from left to right. We're used to doing that. So you got to look for the E or the regular letters and get to the E prime. Yeah, it's easy to do that. And then you're also used to thinking opposites, because when we did circles, it was all opposites, right? But now if they mean +4, you truly go in the positive direction. It's easy to do that. And then test it out, guys. Okay, and then we can check it for another point. So -4 + 3. 1, 2, 3, 4. 4 left, up 3. 1, 2, 3. We could check it numbers wise too. Okay, so if I checked it with H, we'd be at 6, 1. According to this translation, to get to H prime, I would subtract 4 to the X and add 3 to the Y. That would put me at 2, 4. 2, 4. Boom. H prime. So just, you gotta look carefully with these translations. Carefully as you can. And remember, if you have taken this test and you're like, I don't think I look carefully, I'll just give you another shot. It's all good. Reflections. Now, this is something I want to address because when I was grading the homework, I saw a few errors here. Reflections do not change the size or shape of an object, but it does change location and orientation. It's like a flip, a mirror image. I want you guys to look, do me a favor, look at this image here. We can use kind of the trick that Mr. Tyler was talking about before. And if we have this figure here and we want to reflect it over the line, all you really have to do is just count how far away from that line it is. So see how C is 2 spaces away from the line? That means C prime also has to be 2 spaces away. And the same with B. B is 1, 2, 3, 4, 5. We'll go the other way. 1, 2, 3, 4, 5. So just count it out as much as you can. Try to use that, spatialness, whatever the word for it is. Okay, but it does not change the size or shape. It flips it. Here are the rules of what you do. So it's kind of like with translations. You can either count it out or add it. For reflections, you can count it out or do the rules. Okay, if you do a flip over the y-axis, the x changes negative, the y has no change. I know, you rules. If you flip over the x-axis, there's no change in the x, but there's a change in the y. It goes opposite. And remember, if your coordinate started as negative, a negative coordinate turns it positive. If you flip over the y equals x line, so that's like that line. Okay, if this is my x-axis, this is my y-axis, this is the y equals x line. And then if you flip over the origin, both of them turn opposite. Sorry, Casey. The worst, I know. I hear ya. Okay? Cool. So remember, we're counting or we're following the rules. Does anybody need to copy these rules down? And if you don't feel like doing it now, you can easily look them up online. Just type in reflection rules. It might have been something we went through quickly, but yeah, it was. It might not have been on the Moodle page if that's what you were going by. I'm not sure. I would look at it. I'll have to look at that again. Are you writing this down, Beth? Smart. Very good. Alrighty. Next one. Oh, I thought that all right. So we'll do a reflection across the origin. Okay. So we'll just come up with some points. So someone give me a point. Random point. -4. What do you think? -4, 2? Should we do that? Let's do that. Okay, so if I want to reflect this across the origin, oh, 7. Okay, I'll fix it. -4, 7. This baby, she keeps falling asleep and then waking up. Crazy baby. So, if I want to reflect this across the origin, what would I do according to the rules? What does the rule tell us to do? Someone type that in chat. You can explain it. You can type what it says. I'm going to give her to Nana. I'll be right back. Okay. What does that rule tell us, friends? Again, I could look back, but I don't wanna. I'm testing who wrote it down. No, I'm just kidding. I can look back. So if we reflect over the origin, according to this rule, we make both of our points opposite. So what would that point turn into? -4, 7. We wouldn't flip them. What you did is you flipped them and turned them opposite. You're probably thinking our rotations. That's what you're thinking. Did you spit out your Nana again? She's smiling at me like, yeah, I did. You okay, babes? So Beth, as I'm doing a crazy reach here, there we go. What you did is you kind of flipped it completely. So, oh, Dallas, I saw that, Dallas. My bad. So what Dallas did is he took the Y and made it opposite. Dallas, what you did is you did a reflection over the x-axis. According to the rule, if we want to flip it over the origin, we have to make both of them turn opposite. So it would be like Allie says there. Yeah, very good. According to the rule, if we want to flip it, we would make them both turn opposite. So 4, -7. We don't make them switch places. Beth, you turned them opposite, but then you made them switch places. Oh, and then you did another one. And that one, Beth, was just, you just didn't make the X go opposite. That's what it was, okay? So it makes it opposite. Let's do a reflect. Let's do the same point, but a reflection over the x-axis. Do you guys remember which one turns negative when, or opposite, when you reflect over the x-axis? Hold on. Oh, did you put a bow on the kitty? Oh gosh. Okay, so which one turns negative if we reflect it over the x-axis? Does the x turn negative or opposite, or does the y? The 7. Yeah, that's going to go opposite. So when you reflect over the x-axis, the y goes opposite. So then we're going to take that y and we're going to make it a -7. Good. What about if I reflect over the line y equals x? No, Mom, I can't FaceTime. Stop. Gosh. My mom gets bored when she goes through chemo, I tell ya. So the y equals x. What happens there? Looks like they switch places, right? We don't make them opposite, they just switch places. So what would negative 4, 7 turn into if they switch places? 7, negative 4, yeah. You got it. And now if I reflect it over the y-axis, which one's going to turn opposite? Yeah, good, Wolfstalker. You got it. It would be the x turns opposite, so it turns into 4, 7. Beautiful. That's it. That's the rules there. It's good to see those in number format, so I would take a picture of that maybe. If you're not going to use it, don't take a picture of it, but it's helpful.
No, no. Oh,
Elizabeth, leave the cat alone. Come on.
you're breaking my phone.
It's all right.
That's it. Come back here.
Lizzie. Lizzie, that might not feel good on Kitty. It might not feel good, honey. It's okay, Kitty. She's hiding. All right. Questions on reflections. Oh, there's another reflections. All right. So which one shows a reflection across the y-axis? So if those are, it shows the original points. Which one is a reflection across the y-axis? Remember, if you're reflecting over the y, the other one turns opposite. Which one? So if we're reflecting over the y, the x is going to turn opposite. What do you guys think? If you picked number 3, that would be where both of them turn opposite. That, oh, no, I didn't want to do that. That would be a reflection over the origin if they both turn opposite. 2, yeah, it's definitely number 2. Because in number 2, we're reflecting across the y. That means the x goes opposite. So the x went from a positive 3 to a negative 3. Okay. Oh, Kitty. You okay? Yeah. Oh, she just wants you to wear a bow. We'll get her going. Okay. Good. So it's definitely number 2. Take your time with them. Oh, I see the Nala baby. Nala, I bet you don't get tortured with wearing bows. Okay. So, check this one out. What do you guys think? In Polygon Laugh. That's a good name there. All right. If that's reflected across that line, will the new coordinates be 1, 7, 4, 3, 2, 0, 4, negative 3, and 0, negative 5? What do you guys think is the best way to check if that's true? What should we do? How should we tackle this to determine if it's true or false? Well, that's not going to help us, Casey. No. Just kidding. I know, I get it. I feel your pain. Beth, what do you think? Wow, that sounded really insincere, but I seriously do. I feel your pain. I'm exhausted. I did ringside yesterday. My kickboxing class that I used to do in Wisconsin, I finally started it up again. It was so awesome. My knuckles are like fried, but it felt really good to punch stuff. Yeah. A bag. It was a bag. Okay, no problem. No problem. So what do you guys like? Should we graph it out, you think? Say yes, we totally should. Yeah, let's do that. So we're gonna graph 1, 7. That's L. 4, 3. That's supposed to be A. Right away, we can kind of tell. Look at where A is. We can label them. So 1, 7 is supposed to be L prime. That one, check it out. It's up here, and now we're down here. And A prime, uneven, totally. It should not be uneven. It should be the same distance away. It should not move at all. It just should flip. So this one is definitely going to be false. So if you encounter a question like this, I would plot it. You know, I can tell you where to get some screenwriting tools. Totally. Epic Pen. It's good stuff. Otherwise, there's Web Paint. Allie's very proficient with that. You can talk to her about it. But yeah, definitely false. I would plot it. Let's talk rotations, friends. Let's rotate. A rotation just rotates an object. That's it. Doesn't change the size or shape, but it changes the orientation. So where it is. No, antisocial. Okay, don't ask Ellie. Ask Kaden. Kaden knows too. Okay, these are your rotation rules. Here's where it gets a little crazy. Okay? Because if you are moving a point 90 degrees counterclockwise, 270 degrees clockwise, good thing is you guys won't have to like think through what that looks like. You really won't. You just have to read what it says and bam, follow this rule. That's it. So if I have the point 3, -4, what would that point change to? If I did a 90-degree counterclockwise rotation or a 270-degree clockwise rotation, what would that turn to? 4-3, Beth says. Is she correct? I think so. Yeah, because the X and the Y would change places. So they would first flip, and then what was the Y goes opposite. Yeah, I totally agree. Good job, Beth. Go Beth. Go Beth. Okay. Then if we do a 180-degree either direction rotation, what would our 0.3 and -4 turn to? It looks like they both go opposite. What would 3, -4 go to? What do you think? They don't flip. They don't flip. They just turn opposite. Yeah, good. If they both turned opposite, it would be -3, 4. Just the opposite sign. And then what about a 270-degree counterclockwise or a 90-degree clockwise? It looks like they flip, and then what was the X goes negative. So they flip, and what was the X goes negative. But the Y stays the same. Yeah, Wolfstalker, you got it. Oh, did you spit up? Yucky, yucky. Not Wolfstalker, the baby. -4, 3. Perfect. Perfect, perfect. I'm going to switch to the next slide. Okay. Oh, and we kind of did that already, so I'll skip that. All right, dilations. Let's talk about dilations. Okay, I'll be right back.
What's the matter? What's the matter? What's the matter, you? Oh, baby.
We're grunting. Oh, we had a big burp. I hope you guys heard that. That was epic. Okay. So, we won't tangle the baby in the wires. There we go. There we go for baby. Okay, a dilation, Evelyn, you need to learn this, is it makes an object, oh God. Oh, we are like puking. That's not good. Oh, baby girl. Sorry, baby. Ick. That was a lot of ick. Okay. Wow. Look at us right now. All right. Sorry, guys. A dilation simply makes an image bigger or smaller. It does not change the shape of the object, but it enlarges it or reduces it. The amount that the object is enlarged or reduced is called the scale factor. Okay, so this looks really complicated, but sometimes you will see that they will give you they're saying to get A prime, you take the original point A and multiply by the scale factor. If your scale factor is a fraction, that means that it's a reduction and you would divide. So if with scale factors, you're either multiplying or dividing. That's it. Does that make sense, guys? It looks really complicated, but if it's a fraction, oh, apparently I can't spell fraction. If it's a fraction, it's a reduction. If it's a number, like an integer, it's an enlargement. So, yeah, and then again, the same scale factor has to work for all of these. So all of these should be divided by 2, and it does work that way. So, still with me? I know I'm dealing with the nasty baby here. She's not nasty, she's just really irpy. Okay. All right, so if we have this dilation here, where triangle XYZ becomes triangle X prime, Y prime, Z prime, what is the scale factor? What do you guys think it is? What did they do to get from X to X prime and then Y to Y prime? Looks like our numbers are getting smaller. It's definitely a reduction. So we're looking for what kind of a scale factor? Two, yeah. What do you guys think? Looks like our numbers are getting smaller. If you look at Z, Z goes from 12 negative 1 to 4 negative 1/3. So they definitely divided by 3 to get that point. And if you divide, that means you have a fraction scale factor. Okay, guys, so if you divide, if your points get smaller, it's always going to be a fraction. And remember, it just means you divide by 3. We don't need to be like, oh God, it's fractions. Right, Evelyn? We don't get scared of fractions. No, we don't.
I'm sitting here confused as heck because if you look at Y, it's add 2, subtract 4.
Why here?
Yeah.
Right. It is possible to look at these and see how you get them from adding or subtracting. It is possible. It totally is. But with dilations and enlargements, you will never have to add or subtract. That is only for translations. So with dilations, it's only multiply or divide. So I get it. Yeah. So you should only be looking at, okay, to get from Y, are they multiplying by something? Well, that wouldn't make sense because we're going from -3 to -1. So they're definitely dividing. But I get it. You could get it by adding. It's just, we're going to put it out of our head because adding deals with translations. Does that make sense, Allie? That was a great question, by the way. Okay. Cool. Cool. Okay. So an enlargement is a type of dilation where the value of the scale factor, oh gosh, you're irpy, poor baby. The irpy baby today. What do you guys think? Is this true or false? An enlargement is a type of dilation where the value of the scale factor is greater than 1. Yeah, that's totally true. A reduction is a type of dilation where the scale factor is less than 1. And I don't want you to think negatives, guys. I want you to think fractions. So that is definitely true. Okay, the length of a rectangle. 1 second, Peanut. Is 33 inches and the width is 67 inches. The rectangle is enlarged. So what are we going to be doing here? Multiplying or dividing? Multiplying. Yeah, definitely. So you're going to multiply by 1.2. Oh, okay, toss it. What are the new dimensions? So someone multiply that for me. What's 33 times 1.2? And 67 times 1.2. That'll give us the new dimensions. $35, good. Is that what it is? I'm saying good, and I'm like, I should check this. 33 times 1.5. Oh, 1.2, duh. I didn't get 35. 33 times 1.2. Yeah, I got 39.6 and 80.4. That's what I got. Beth, check it again just to make sure. 80.4. Okay, good. Good checking. That's okay. That's why we do this. So the new dimensions would be 39.6 and 80.4. And again, we're just multiplying by that scale factor. And that's all I got. Boom. We made it. We're not as... And it looks like, guys, it is till midnight. So you should be available till midnight. I will double check my settings and all that. Okay, bye, guys. Have a good day. You are free to go. You're free. You're free. Bye.